Hey everyone, welcome back, and today let's solve Leetcode problem 1920 titled Build Array from Permutation. So I'll try to make this video as quick as possible. The problem statement is very clear. The examples are also just as simple. Right, so we're given a zero-based permutation nums, that's zero index, and we want to build an array answer of the same length as our input array nums, where answer at index I is equal to nums of nums at index I for each index I in the range of the length of the input array nums. And we want to then return that answer. And then you quickly define what a zero-based permutation is. It's basically an array of distinct integers from 0 to nums.length minus 1 inclusive, basically the first index to the last index inclusive. So in example 1, we see we have the input array nums to be 0 to 1, 5, 3, 4. We see the output is hence 0, 1, 2, 4, 5, 3, because answer at every index I is equal to nums of nums at index I. Taking a quick example here, answer at index 0 is equal to nums of nums at index 0. What's nums at index 0? It's 0. And so what's nums at index 0? It's going to be the value 0, and that's why for I equals 0, we have our answer at index 0 to also be 0. And similarly, we apply that same logic for all the other indices I, for all the other values in the answer array, and notice how it is the same length as our input array nums as well, of a length of 6. So for the constraints here, we see that the length of the input array nums is going to be between 1 and 1000, and the value of the input array nums is going to be between 0 and the length of the input array nums itself, of course, to be able to accurately build it for all indices I for the answer. And of course, the elements in nums are always guaranteed to be distinct, to not enter a cycle of duplicate elements. Right, so let's go ahead and quickly finish this problem up. And like the problem statement says, we really just have to build the array, auxiliary data structure, answer, and fill it out using this rule that they give us right here, right, very straightforwardly. And so doing that, we just initialize answer. We know it's equal to the length of the input array nums, rather it has the same dimensions as the length of the input array nums. And so I'm just going to use 0 as a placeholder. So it's going to be basically filled with zeros for all indices I with the same dimensions of the length of the input array nums, because of course before we actually iterate through the input array nums to build our answer, we'll just use 0 as a placeholder value for all indices I. So now let's actually build the answer, and the way we can do that is for every I in the range of the length of the input array nums, let's apply the rule that the problem statement outlined for us. Answer at every index I in this range of the length of the input array nums is going to be nums at index I. We're basically doing exactly what the problem told us to do. And effectively, once we do this operation and set answer at index I to be equal to this value for every index I in the range of the length of the input array nums, we effectively just return our answer to whatever it is after applying that operation. So on this I made any syntax 0, 0, there should be accepted, and there should be a valid solution. So let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So, quite straightforwardly, the problem statement really told us exactly what to do. It highlighted the rule for us. It told us how to solve the problem. It gave us the real main chunk of code. All we had to do is really just initialize the answer array with the same dimensions as the input, iterate through all indices I in the range of the length of the input, and apply that rule, and effectively return what our answer auxiliary data structure was. And so for that auxiliary memory usage, we know our memory or space complexity is going to be big O of n, and our runtime complexity is also going to be linear, really because we iterate through every index I or every value in the range of the length of the input array nums, which we can denote as n for the runtime complexity to also be big O of n. Right, so if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.